All right, what's up, guys? Let's do the rest of the notes. So this is continuing basically what we did the other day with certain examples in the notes. Okay, so before I start, I gotta show you a minion of the day, right? What do I got for today? Yeah. What do I got? Okay, let's do this. This is one of my favorite guys ever. It's a Silver Surfer. He's silver, and he surfs through the galaxy. That's pretty dope. Okay. Okay, that was dope. Okay, nice. So let's get started on Connie. Favorite girl in the world, Connie. She's a cutie. Okay. There we go. There's Connie. All right. So with a cone, we're gonna do the same idea as we did earlier. Oop, burped. As we did earlier. We're gonna find the area and the volume of this thing. Okay. So here's the thing: area of a base. The base of this thing is the circle on the bottom. Okay. So the area of base is really chill. There's only one base. So that would be pi r squared. The radius is 12. So it's pi times 12 squared, which is 144 pi. All right, so the base, easy, because the base is the circle. Okay, so in our total area, there's only one base in a cone. So we have 144 pi because that's the one base. But then we have to add the lateral area, the surrounding part. So the lateral area is kind of weird here. The lateral area is the curvy, weird cone party hat piece, okay? So the lateral area actually has its own formula. It's a very basic formula. It's pi r L, okay? That will give us the area of the lateral area. So L, all L is, that's the slant height. All right, so it's really nothing bad. The slant height is this piece right here. All right, so with that slant height, what we're gonna do is we're going to find out what that is. So luckily, if you're looking, you're like, well, there is no L. Well, we could totally find it because what we end up having is a right triangle right here, okay? Because again, 90 degrees, goes up and down. We have 12, 15, and then L as the hypotenuse. So we could do Pythag to find what L is. So that'd be leg squared plus leg squared equals hypotenuse squared. I think that's 225, but I'm a Jamoke and I don't know what I'm doing. 15 times 15, yeah. So 225 plus 144 equals L squared. So L squared equals 369. Is that part of a rap song? 369, one more time. Oh my gosh, what is that? That sucks. We're just gonna leave it as the square root of 369. Oh, this sucks. That doesn't break up. Yeah, that's it. Dang. Oh, actually, we could break it up a little bit. This is 3 times 123, and that's 3 times 41. I don't think 41 breaks up, does it? No, I don't think 41 breaks up. So what that ends up becoming is a pair of 3's. This is left over. So the slant height is 3 square root of 41. God, Woof, this is an awful number. Okay. That was fun. So the lateral area now, once we find this, and again, this won't always be ugly like this, is literally pi times the radius times the slant height. All right, and again, very basic answer, because if you think about this, 12 and 3 are out there, so that's 36. There's a pi. I'm going to put the pi here because pi's cute. We could use it as a divider, and there's square root of 41. Dang, that's ugly. I'll go McGee over here. Woof. I don't know why that's so ugly. Okay, but that lateral area could be added here because the lateral area. All right, and then again at that point, very basic. We know that this is the answer because these won't go together nicely. Okay, this area, it's just the base plus the lateral area. But just remember, pi r L is a really important little formula for the outside of a cone. All right, and again, you can put that up here if you want to. Okay, the volume is actually very simple, okay? We basically, whenever we do volume, we always go based off of what we've been doing earlier, the area of base times height. But in this case, a cone is 1/3 area of base times height. Okay? So whenever you have a cone or a pyramid, 1/3 goes in front here. But it's the same as what we did before, because before we did area of base times height, but now it's just 1/3. Okay, so just make sure you're doing that for cones and pyramids. So in this case, we did 1/3. The area of the base was this. And the height of this thing, again, is from bottom to top, is 15. Okay, so we can multiply that out. 1/3 times 144 times 15, 720 pi. And that we could put units cubed because that's a cute little fun thing. Okay, hope that made sense. But again, this is the main idea here, is that it's just like normal, just like what we've been doing earlier, but now this has 1/3 since it's going to a point. It's not all the same the whole way through. Beautiful. Awesome. Let's go to the back. Okay, a square pyramid. Okay, love this guy. All right, so area of the base. Okay, the base is a square. This is super easy. So we only have one base. So since it's a square pyramid, this is the base. So that'd just be 10 times 10, which is 100. Just like the emoji. Haha, cute. Easy. Okay, this is the fun part. The lateral area are all triangles, and there's 1, 2, 3, 4 all around it. So what I'm going to do is I'm going to highlight this one here because this is going to be the important one. Okay, yeah, this is where it gets fun. Okay, so think about this. To find the lateral area, there are 4 of these like sideways triangles all around. Okay, but what you luckily know is this. If I want to find the area of a triangle, that's half times base times height, right? So there are 4 triangles, which means I'm going to do 4 half times base times heights, right? Because there's 4 of them. There's this one, there's the one up here, there's one to the side, and the one in the back. Okay, so look at this triangle. We have the base as 10. That's easy, right? But the height is where you got to be careful. The height of this thing is you got to think like if you're leaning against a wall, here's your head, and down here's your feet. Okay? Your height is going to be this distance, right? Imagine you're leaning against a wall, right? And you don't say your height's from here to here. That's not your height because it's from your feet to your head. So the height is this slanted piece that we need pretty badly. Well, think about it. It's really not that bad to find. We know that... oh, what am I doing? Oh my god, I'm such a jamoke. Okay, we know that this is 5 because it's a radius. What am I doing? I feel like I need something else. Oh my gosh, I'm such a jamoke. Look at me. I'm like freaking out because I didn't see this. So we know that this is 5 because again, whole thing is 10. This is 5. Okay, and if we want to find this slant height, we don't have enough right now to find this distance. But this will help us here. The altitude's 12. That's top to bottom. So that's the height of the pyramid, but it's not the height of this side. Well, very similarly, we have a nice right triangle here that we could work with. If you guys can see my outline. Where we could use Pythag and help find x. So that's 12 squared plus 5 squared equals x squared. That's 144 plus 25 equals x squared. That's 169 equals x squared. And again, I didn't even have to do this because I know x is going to be 13 because it's a 5, 12, 13 triangle. Okay? And if I find that that slant height's 13, remember that's the height of the side triangle here, then I could fill in this information. Half times the base was 10, the height was 13. Again, this is of the triangles, not of the pyramid. So then I can multiply this out. 260. That's the total lateral area, total, from the 4 triangles. So the total area is the one base, which we got before, plus the lateral area, which was 260. So total area is tree 60. Okay, and we can put units squared because it's, you know, it'd be cool. All right. So from that point, not that bad, right? Because we're breaking it down into its parts. But the volume, remember, is very similar to what we did with a cone. If you remember cone, then you can remember the volume for this. Since it's coming to a point, it's not just going to be area of base times height anymore, because it's going to a point, it's getting smaller. So this is the same idea as cone. Same as cone. It's 1/3 area of base times height. Okay. Remember, all of our prisms had this formula, and all of our pyramids have this as a formula with 1/3 in the front. So really not that much to remember. So it's 1/3 area of base, and the height of the pyramid is 12, because hey, this is the height of the pyramid now, is 12. So don't forget that. Okay. So this should be 400 units cubed. Okay. Hopefully that made sense, but kind of read through. Should be pretty basic. You can put that information up there if you want. All right, hopefully the last one. Yeah, this should be the last one. Okay, hexagonal pyramid. Okay, this is the same idea as what we did earlier. Oh, okay, we could do this. Okay, I know you guys sometimes like to do the easy stuff first, the hard stuff last. So let's do that. Okay, the base is the hexagon. Okay, so if the base is the hexagon, that's where we have the weird formula to find that. Okay, so we could wait on that because it's going to take a little bit longer. But think the lateral area. The lateral area has got 6 triangles. Because look, there's all these triangles. This triangle, around, all the way around. So we know we're going to have 6 half times base times height to get the 6 triangles of the lateral area. So we know we have 6, we have half. The base of every triangle is 4. But now we need the height of the triangle. If you think about what we did earlier, where we say, okay, like here's, for example, one of those triangles, right? And it's got all the information I need. It's got the base and the height of the triangle. Again, if you think head and there's the feet, the height is the slant height, which they gave us. Okay, that's beautiful. They gave us the slant height right here. That's 9. So the height of those triangles is 9. Okay, so if I do 3, 9, the lateral area is 108. Okay, but really think in terms of what we did on the last problem with the pyramid, and you should be able to find that. Okay, area of base. We might as well just do it. So the base is a hexagon. God, this is the most ugly hexagon. And we know a hexagon is split into 6 equilateral triangles. Okay? So what I'm going to do is I'm going to take one of these triangles and I'm going to zoom in on this homie to make sure we have what we need. Okay? So think about it. And again, this is kind of like what I'm doing here. I'm taking like that triangle out from the bottom. Okay, that's what we're focusing on. Here's the pink. Just in case you need a visual. All right, so let's think about it. In that triangle, the base is 4. It's a hexagon, so that's how we know it makes it to the 60, 60, and then split into 30s. Okay, which again would mean that this piece is 2, and the height is 2 square root of 3, based on our 30, 60, 90s. So the area of that triangle would be half times the full base times the height. So the area of the triangle would be 4 square root of 3. That's one triangle. But there are 6 triangles in a hexagon. So we take this number by 6. So the area of the hexagon is 24 square root 3. Okay? Basically all last chapter. So just kind of look at the visuals and you should be able to find all of that. Okay, maybe this will help too. Keep that all color coordinated. Okay, total area is the area of the base area of the base, which is 24 square root of 3. There's only one base, plus the lateral area, which is 108. Okay? They don't match in terms of radicals, so this is the total area. Beautiful. Love it. Oh, this is, oh my, oh, wait, what? Oh, this is going to be so bad. I probably don't even know how to do this. Okay, volume. It's a pyramid. So this is 1/3 area of base times height. Okay, woof. This is what you get when you don't come prepared with the answer key. What a jamoke. Okay, the volume is 1/3. The area of the base is 24 square root of 3. That was the base. And the height, we don't know yet. Oh, woof. So we don't know the height. So remember, the height in this picture is from here all the way up. Oh, this is going to be so bad. Oh, this is awful. So if I need the height, I need to make a right triangle, just like this. Oh my god, this is going to be so disgustingly bad. Okay. To find that height, what we're going to have to do is make a right triangle, and I'll shade it in like this. And we're going to have to find all the dimensions of that right triangle to end up finding the height, which is the upright thing there. So luckily we know that this piece is 9. This is 9. But then this piece, oh, this is so stupid. This piece here is the height of this triangle, which was 2 square root of 3. Okay, that's what this little piece is, 2 square root of 3. And again, look back over here to kind of see the height of that triangle, right, was 2 square root of 3. That's what's being shown here. So, oh my gosh, this is so bad. So what we have to do is we have to do Pythag, x squared plus leg squared equals 9 squared. Oh, this is so bad. Okay, it's fine. It's fine. Just copy me. Okay. This is x squared. Oh my gosh. Okay. 2 squared is 4. Square root of 3 squared is 3. So that's really 4 times 3. And this is 81. So x squared plus 12 equals 81. That's 12. X squared equals 69. And if I square root, oh my gosh, I hate this. We could just leave it as the square root of 69. This is the height of the pyramid. Oh my god, woof, that was awful. Okay. So there's the height. Whoa, that zoomed out a lot. Okay. And then at that point, that's our height here. Oh my gosh, this is just so awful. I'm so sorry. And the volume, 1/3 of 8. I'm sorry, 1/3 of 24 is 8. Square root of 3 times square root of 69. We're just going to leave it like this. Square root of 207. I'm sorry. I hate this problem. This is the worst. Okay. Would be this. And that's totally fine to leave it like that if you want to. Okay. That's all I got for this. Just make sure you're doing the next thing in the notes. It's going to be the surface area practice. I will put the answer key to that on so you guys can see that. Okay, bye.